consider this an array. And we have, how many statements do we have here? So we have here two statements, such as the assignment statement and the looping statement. So all of this will be part of the looping statement. So let me just clear this a little bit. It's too thick. So let's start with the course. Then we have the data segment. So with the data segment, we have here the given messages. So DB 10, 13. So we have here even. And for the add, as well as initialization for Y, initialization for I, and the initial array, which contains 1, 4, 5, 6, 8, and 9. 1, 4, 1, 4, 3, 5, 6, 8, and 9. Then on to the code segment, which has the main procedure. And to initialize the data segment register, we have to move that first to the accumulator. So move PSAX. So now we can proceed to our to the statement, the looping statement itself. But first, we have to address the content, which is the array. So since this is an array and each of these required variability, so we will be using, so we can use either the indirect addressing or the base plus index addressing. So we will be using now the indirect addressing. So with that, we have load effective address bx, whatever the address of string x. And now we have to compare I against 6. What is that? This is the one. So the equation is less than equal. So if that is, so the syntax or the algorithm is that all the choices will be in one location. So how many choices do we have here? How many looping statement? So when are we going to exit? So to exit, it has to be greater than. Jump, if greater than, then it proceeds to exit. Otherwise, what it will do, it will do the choice or the conditional statement. How many choices do we have here? So 1 and 2. Okay. So for the relational operator, we have the mod. Okay, so you get the mod and then equate that to 0. So for that, we have to prepare our division. So move BL, that is 2, and initialize the accumulator with 0, and then move the data, since that is a byte, from the memory using the indirect addressing to the lower accumulator, and then perform the division. Okay, so in this case, what we need is the AH, which is the mod. Okay, so the modulo or the remainder. Okay, so now we have a value for the AH. So let's compare. How many choices do we have here? We have 1 and 2 choices. Okay, so compare AH against 0. how it will be false if that is not equal. So jump if not equal. Um, so if false, if even, so let's just make it if even. Otherwise, for the next choice, we have to check if that is there's an AND operation here. So that means let's compare AH with 1. If this is false, how it will be false? So jump if not equal, so else if false. So if that is true, you have to AND it or compare it with if the content is greater than 3. So with that, so let's compare whatever the content of px, if that is 3, how it will be false if jump if less than or equal the value of less than equal, we jump to else if false. Okay, otherwise it's true, so therefore it has to output a string. So move AH9, load effective address DX, whatever the string in odd, and interrupt 21H. And then also, after this operation, what it will do, it will also increment Y. So we have here increment Y and output the move AH2. So move DL, whatever the content of Y, and interrupt 21H. So after which it will, so after this operation, what it will do, it will increment the counter. So that will be increment I. Yeah, increment I. It will go to the next element, which is 4. So how do we proceed to the next element? So increment bx, okay, and proceed with the looping. So to loop, we have jump. Where are we going to start? So we start with comparing if that is I less than equal to 6. So we will be repeating ulit. Okay, now so what else do we need? So we will be needing the for the label if even. So we have here if even. What does it do if it's even? It outputs the, so move AH9, so load effective address DX, whatever the even, okay, interrupt 21H, and then after you output the even, it proceeds again to Y, increment Y. So let's call it Marie. Okay, so let's jump to Marie. Okay. Are we done? I'll just move it here. So we proceed to jump Marie. Okay, so then what else do we need? So we will need in also, so for example, this is false. So if this is false, will it proceed to the next element of the array? No. What it will do if it's false, what it will do if it's false? It will proceed with y++, correct? So which means we have to jump to Marie. So which means, what do we have to do? So else if false, it will jump also to Marie. Okay? And after which we proceed with the exit. So we have here exit, which is move AH for CH and interrupt 21H, and uh, terminate the procedure and end. Okay, so that will be the solution. So I have here the another emulator, which is the 8086, which is uh, one-stop shop program that enables you to write the assembly language program with its environment. So after we've already done the no, not this one. This is not the one. Wait. Okay, so we have this. So we have here the even and the odd. Okay, so jump if greater than the x. Okay, so we have here. So if even. Okay, so I just have to delete this one to make it consistent. And then voila, we have this. Now let's run the program. So as you can see, we do the emulator, or we can do this step by step. So in the step by step, you will be able to see the content of the, you will be able to see the line being executed. We can also see, so view the content of the memory. So this is the memory, and let's see the address of the data segment. So the data segment is at 07100. So we can have here at 00, and then for the offset we have 100. So as you can see, we have here the even, odd, and so on. Okay. So as we step our way to the program, you will see the value changes. Okay, so we have here the I. Nah, I becomes 1 this time. No, not yet. So we have here 0, 0. Okay, we have the 1, 4, 3, 5, 6, 8, and 9 for the X. Okay, so which means the address of the X is at memory location 0710F. Okay, so let's see. So kung jump if greater than exit, so you may also see the flag register, which having the different flags changed as we move on to the process. So we have here move DL. So as you can see, it changes, it highlights whenever the value in the register is changed. So these are the different registers. So this is the hexadecimal equivalent of this instruction. So for this instruction, how many bytes does it have? So it makes use of 3 bytes. Okay, so single step again. Now for the BX, as you can see, our BX contains 00F, which is true. This is 00F, right? So 0, the offset, 100F. So div DL, it gives us 00. Okay, with higher accumulator that is 1. So compare AH against 0. Jump if equal, then it will proceed to if even. Okay, so since it's not equal to 0, it proceeds to the next statement, which is compare AH is equal to 1, which is true or false. So that is equal. Therefore, it doesn't proceed to the else if false. Otherwise, it evaluates the and. What is the and? Compare bx against whatever the content of indirect addressing bx with the value or immediate value 3. So jump if less than equal. Is this true or false? That will be true because that is 1. So therefore, it jumps to else if false, which gives us the instruction to jump to Marie, which increments the value of y. Okay, change the value of ah with 2. Output the ASCII character of y. Okay, what is the value of our y here? So here is the y. Here is the y, which is 1. Okay, and let's step through. So 0 becomes 1. Okay, and jump ulit. What do we have in ulit? So compare compare I against 6. Okay, jump if greater than, which is false, which means we proceed to the next statement. So I will just run it through. Okay, so as you can see, we have here the given output, which is what is our value? So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, and 7. Okay.